Hi, I am John Ranstrom, Principal Software Engineer at Moffett and Nickel. I'll be talking about digital twins today with FlexTerm as the software system supporting digital twins. First, some vocabulary. CT, container terminal. You've seen container terminals at ports around the world. Offshore wind, OSW, offshore wind. These are big windmills out in the ocean. A TOS terminal operating system. This is the software system that controls a marine terminal or other kind of terminal. So often with a container terminal, but also other kinds of terminals. Equipment control system. Controls the equipment that operates within a container terminal or offshore wind terminal. Simulation. So this would be a digital twin model that includes simulated TOS, the simulated ECS, and simulated cranes and trucks, etc. In contrast, emulation has a digital twin model that includes the actual TOS, the actual equipment control system, but still has simulated cranes and trucks, etc. So let's do this in more detail. Simulation as a simulated TOS, terminal operating system and equipment control system within the total system, as well as the digital model and FlexTerm as the simulation engine. That's simulation. In emulation, you take the simulated TOS and ECS out, and now you use the real terminal operating system, the real equipment control system, connected to the digital model in FlexTerm. Another view on that, which may make more sense, is here in this blue box. We have the real terminal operating system with the equipment control system, not shown in acronym here, but it is running the system as far as it knows. In production, it is sending messages to the real cranes, the real trucks, to move containers about in a container terminal. In emulation, it is sending the same messages and believes it is operating real equipment, but actually those messages are going to FlexTerm, which is running simulated equipment. So that's the contrast between emulation and simulation. You might wonder about how do you build the model? Well, there's some tricks that make it pretty easy. Most terminals will have CAD drawings prior to construction, and those can just be read in the model generated from the CAD drawings. Or if there's an operating system somewhere, the TOS, the terminal operating system, will have its own model, and FlexTerm can extract that data and produce a digital twin model for that. So let us look at a simulation running. So this is a terminal that has not been built, but will cost over $1 billion to build. You'd kind of like to know that it's going to work. Now, it's so expensive because this is an almost completely automated terminal. You see here, these are robot trucks, no people, no drivers. Okay, these are robot gantry cranes, no drivers in the cranes. It's fully automated. And the key cranes here, the ship-to-shore cranes, may or may not have people in the cabs. Often there's still people in the cabs, even serving the rest. So that was simulation at a container terminal. And this is very useful to test different kinds of layouts. For example, um, should these blocks of containers, should they be oriented in this direction, or should they be oriented perpendicular to the berth where the ships are? That's a very important question. What's going to give better performance? It's hard to know unless you run a simulation. Then you can get the answer pretty easily. You can just try it both ways and get the answer. And it's useful to have the right answer before you pour the concrete. Now, here's a different kind of terminal, and this is an offshore wind terminal. Now, what does that mean? Offshore wind is just big windmills out in the ocean. But how do those get built? There are specialized terminals, marine terminals, that whose purpose is to gather the components needed for these windmills and um, load them onto the ships, where the windmill is partially built onto the ships, and then the ships bring them out to the ocean and finish erecting the wind terminals out there. So this is a big logistics problem in its own right, and it saves a lot of money if you know the terminal is going to function properly. So a FlexTerm digital twin models this operation, and we can see over time if the yard gets too full with blades or too full with nacelles or with the tower segments, and we can see if there's a bottleneck of too many ships on berth at the same time, or ships not loading out fast enough. All those kinds of things translate to just millions of dollars. So it's really useful to know if it's going to work before you build the terminal. And then even after the terminal, you can modify production parameters and tell if it's going to work well and how to improve your operations. So that is a simulation of an offshore wind terminal. Let's look at an emulation. So here we have FlexTerm, and you can't really tell. I mean, it just looks like FlexTerm. It could equally well be a simulation, but in this case, it's not a simulation. This FlexTerm is connected to the real TOS, the real equipment control system, to do the work, and FlexTerm is simulating the trucks here and the cranes. So in just a moment, you'll see a view of the real TOS and its screens. And here's the real TOS. And this is just a kind of funny consequence of this. Remember, FlexTerm is a digital twin. So it's a digital twin, not quite of reality, but of the terminal operating system's reality. In this case, the terminal operating system has a data error. This container is floating, which of course is not true. Really, the container is down here, but there was some sort of data input error such that this container was thought to be in tier 5 instead of tier 2. And FlexTerm, being a digital twin of the TOS data, shows this. But you can see it easier in FlexTerm than finding it in the TOS. And users then fix this data typically once they learn about it. They just fix the data and then things run normally. So in this case, the data is fixed with the TOS check tool, and they'll just check this container down, and you see FlexTerm just follows along and maintains consistency with the TOS data. So the point of this is you have the TOS, the real TOS, the real equipment control system operating, and the TOS and ECS think they're running the real terminal. So you can do these fabulous tests that you could never do in real life. You can try all kinds of things in just a few hours and determine if the operation will work better or not as well. And once you prove that when you try something different, it works better, then you can apply that into production and get the benefit, which means saving lots and lots of money and loading ships out faster, serving the public faster. So that is very valuable. So we have learned here that there are 3 sorts of digital twin that I have shown you: container terminal simulation, marine terminal simulation, and marine terminal emulation. Of course, there are other kinds of complex operations that digital twins can be built for, and FlexTerm supports others, but this gives you an idea of what digital twins are for.